And so let's plot where Sitka, Alaska is going to be over here. So it was 135 and 57, so right around in here, and that was our... And so for this one, remember we calibrated a distance of 1,450 miles. So what you're going to do, make sure you use miles here, and we're going to calibrate our compass to go from 0 to 1450. So 0 is there, and then 1450, probably better do it this way. So 1450 is going to be right around, and you can draw a little line to mark where it's going to be. So I've calibrated my compass to 1450 miles. So now I'll go to Sitka, Alaska. I'll push hard down there, and I'll make a circle radius of 1450 miles. So somewhere on this circle is the earthquake. I don't know. So that's why we need to use 3 different stations to locate one point. So again, you'll be finding Honolulu. So Honolulu is what was 158 and 21. So Honolulu is going to be right in here. And then Charlotte, we said, was at 81 and 35. So it's going to be right in here. So that's going to be Charlotte right there. So again, you'll put your compass there, draw your circle of whatever distance it is from Charlotte. Remember we said it was 1450 for Sitka. You'll figure out what Hawaii is, and you draw that circle, and then they should locate one point. And so you'll see how it goes there, and then you'll determine the epicenter, and then see if you can figure out what major fault occurs there. So maybe we'll come back to that. But now let me show you how to do this on Google Earth. All right, so what you will need, you're going to need Google Earth Pro, and you can't do this with a Google Earth Chrome. You need to download the older version of Google Earth Pro. And it's free. You can just find it online. Just look for Google Earth Pro and you'll find it. You can download this version for your desktop, right? For your desktop. We're going to locate Sitka, Alaska. And so remember, for Sitka, Alaska, we had latitude and longitude of 57 degrees north and 135 degrees west. So to enter that in Google Earth, there's a section up over here in the upper search column here. So we'll enter that 57 degrees north, comma, and it's going to be 135 degrees west. And we'll hit enter. And then, so now it's going to take us over here to Sitka, Alaska. There it is, right on. All right, so there's our pin for Sitka, Alaska. So now what we're going to do, we're going to draw a circle. And so there's a tool up here. See this ruler tool? You want to click on that ruler tool, and you want to draw a circle, and then click on the circle. And since everything we were doing so far has been in miles, right? Because it's miles. We want to make sure the units that we use are miles. So let's change this to miles from kilometers. So there's miles. And now what we want to do next is we're going to click right on that. Let's zoom in a little bit. Right on that pin. Just click once. And then you can see how we can draw the circle out here. And down here in the little box here, you see it's the miles getting bigger and bigger and bigger. And so now we're at 4,005. So we need to zoom out a little bit and go over here to 14. They're at 1460. See how close I can get it to 1400. So 1400, that's about as close as I can get it. So the second time you click, then it locks it into place, right? And so now let's save it. Let's click the save button here. And then this little menu comes up. Let's just call this Sitka, Alaska. And hit OK. And then that should appear here in our temporary places, Sitka, Alaska, right? So there's our circle for Sitka, Alaska. And so now the earthquake is somewhere on this circle here. Actually, let's actually do a second one just to kind of get us going. So since we're doing another one of these later on in this lab, let's just go ahead and do a second station. We'll do the Charlotte station. And so for Charlotte, let's figure out our P wave arrival. And so if we bring this right at the beginning, you can see it's coming in at about 808.5, right? Right. So there's the P wave arrival. Now for the S wave, we'll just move this bar over. There's S wave arrival right there. Looks like 813.4. So now our job is to figure the S minus P interval. So again, using our calculator here, we'll take our 13.4 7.4 minutes minus the 8.5. And that gives us 4.9 minutes. So it's almost 5 minutes there. So we'll add that in there. All right, so now that's our distance, our S minus P interval for Charlotte, North Carolina. So let's calibrate our scale over here to 4.9. So in this case, I'm going to click on this, and I'm going to extend this up here to 4.9 right there. So now I have the calibrated minutes of 4.9 here. Now I'm going to move this up, keeping the bottom on the P curve, and then see where it fits between the two curves here. So now I'm touching the S curve up here and touching the P curve. So that's about 2,100 miles, right? So let's put that in there. So now I have the distance for Charlotte, North Carolina. So now for Charlotte, again, you can plot the latitude longitude on here, and we'll do it on the document itself, or let's do the Google Earth just because I want to show you a second circle. So let's go over here to Google Earth, and we'll enter the latitude and longitude for Charlotte, North Carolina. So for this, it's 35 degrees north, and it's 81 degrees west. So we'll enter that, and it should take us over to Charlotte, North Carolina. And there we are, Charlotte. We'll just stop there. And now we want to draw a circle of radius 2,100 miles. So again, we'll open up our little ruler tool up here. We have circle, we have miles, right? So we'll click on Charlotte right on the pin there. Just click once, and then as we move out, keep an eye on the miles down here. So we have 2,099.84. That's about the closest I'm going to get it. So now I have this radius here. So I'm going to save that, and I'm going to call it Charlotte. And then we should see that pop up as one of our temporary places. So now I have two circles. Let's zoom out so we can see these two circles. And the two circles, so now the epicenter for this earthquake is either up here in northern Canada near the Arctic Circle, or it's down here in the western United States. So again, by now plotting the Honolulu earthquake data, then we should see if that radius will be closer to this position or that position. But nonetheless, you will have something that looks like this with three circles. What you want to do is take a picture of this or do a screenshot, and you want to include this with your lab. So alternatively, if you're using the actual sheet here and the compass, so again, for Charlotte, North Carolina, we're doing 2,100. So we'd calibrate our compass to 2,100 right there. And then we draw our circle of that radius, 2,100. So this is, again, showing us that the earthquake is either going to be up in Canada or over here in the western U.S. So now your job is to figure out the one for Hawaii. One thing that you should pay attention to, if the third station, the radius, doesn't fall exactly at one of these points, you can sort of estimate where the epicenter would be for latitude and longitude. For example, if this one ended up having a circle that kind of went something like that, I'm just hypothetical, you see that they don't all meet exactly one point, but you can see it kind of outlines the position. You would pick the center of that point. And the center of that point happens to be at 40 degrees north, and in this case it's 125 west. So 40 north, 125 west. That's how you'd figure that one out. But again, you would pick the middle of where they're all getting close.